So in this problem, we consider that matrix A, 1, 2, -2, -4. And then it says on the grid on the left, draw and label the solution for AX equals -1, 2. If the system is inconsistent, write inconsistent. So, well, AX, I know what that looks like. That's 1, 2, -2, -4. And then X we could just call, it's got to have two entries, right? X, and it's got a vector, just call it vector XY. And then equals -1, 2. So we want to solve that system of equations. What's a way to do that? Yeah, what's the related augmented matrix? The coefficient matrix is going to be just A, right? And then what do? You augment that with -1, 2. I noticed something about these two rows. What do you notice? One's a multiple of the other. Okay, this is your pivot, right? What would you multiply by so that when you add it to this row, you get a 0 in this position? 2. 2. But once you do that, everything zeroes out, doesn't it? Yes. Yeah. Okay. And so what does that tell you? You're going to have one solution, no solution, or infinitely many solutions? Infinitely many solutions, right? Yeah. So what's the related system of equations to this guy? If you use x and y, x plus 2y equals -1. And then what's your free variable? So there's your pivot. Y, so y equals y, if you like. And so what's your solutions look like? X equals -1 plus 2y. Would you buy that? Oh, sorry, minus 2y. And then y equals y. So what's the vector parametric form here? -1, 0. Plus something times y. What's that something? 2, 1 or -2, 1? -2, 1. -2. Okay. So, okay. And so that's xy, right? So can you graph that? So what point does it go through?
0. It goes through -1.
It goes through -1, 0. -1, 0, right there. And then what can you get from the second vector?
Slope.
The slope, right? You gotta be careful here because it's kind of flipped around from what you're used to in terms of thinking of slope as a fraction, right? So what's the rise? The rise is 1, right? Not that you're wrong, but I'm thinking in terms of just the rise. 1, and then the run is 2 or -2. Okay, so you're telling me I'm going to go up 1, and then which direction? Left 2, like that? And then draw the best line you can through those points? Does that make sense? And then if you don't go through the point, what do? Make the point a little bigger? Okay, there you go. And then in part B, we're asked to find the solution set to AX equals 0. If it exists. That's A times a vector X equals a vector 0. That's the homogeneous system. Well, we can use the answer or part of the answer from part A because we know that the solution to AX equals B in this case is -1, 2, is going to be a particular solution, specific solution. For instance, -1, 0 is a specific solution to AX equals the vector -1, 2, since if you plug in 0 for y, you get -1, 0 is a particular solution. We know that the solution to AX equals B is a particular solution plus the set of solutions to the homogeneous system. So all we have to do is delete that, and we've got our solution to the homogeneous system, kind of working backwards. So long story short, the solution to the homogeneous system is just going to be xy equals a scalar multiple of negative 2, 1. So if you graph this, well, that's just going to be, it's going to have the same slope as the orange line that we just plotted in part A, but it's going to go through 0, 0. So it'll look something like this. So the green line is the solution to AX equals 0. And the orange line is the solution to AX equals B, where B is the vector negative 1, 2. And then in part C, you're asked to draw and label the span of the columns of A. But if you look at A, the two columns are, of course, scalar multiples of each other. So the span of the columns of A is just going to be the span of one of these two columns, since they are scalar multiples. So you could, for instance, graph the vector 1, negative 2. So go over 1, down 2. And that's going to be, of course, a line through the origin. There you go. It's pretty close. And again, that's just all the scalar multiples of 1, negative 2. So 1, negative 2 times t, if you like, for a scalar. That's going to be the span of the columns of A. We now have a name for that. It's called the column space. And then in part D, you're asked to draw and label a vector B such that AX equals B is inconsistent. If no such B exists, explain why. Well, it does exist. So if you think about it, B, as we've talked about, is in the column space of A. So in other words, in order for AX equal B to be consistent, your vector B would have to lie on this line. So all you got to do is draw any vector B not on that line, and then there would be no solution. This would not be in the column space of A, and so there's no solution for AX equals B with that particular B, or with any B that's not in line with this line, not parallel to that line.